Welcome to our lesson on the scalar dot product of vectors. This is an important concept in mathematics and physics that you'll encounter in class 11 and 12. Let's dive into what the dot product is, how to calculate it, and why it's useful. Before we dive into the dot product, let's quickly recall what vectors are. A vector is a quantity that has both magnitude and direction. We typically represent vectors using arrows, where the length of the arrow represents the magnitude and the direction of the arrow represents the direction of the vector. The dot product, also known as the scalar product, is a way to multiply two vectors together to get a scalar, a single number, not a vector. The dot product between vectors A and B is denoted using a dot between them, like a dot B. There are two equivalent ways to calculate the dot product. The first formula is the product of the magnitudes of the two vectors and the cosine of the angle between them. The second formula is for vectors in component form, where we multiply corresponding components and then add them up. Let's understand the geometric meaning of the dot product. The dot product relates to the angle between two vectors. As you can see, when we have two vectors, A and B, they form an angle theta between them. Using our first formula, the dot product equals the product of the magnitudes of the vectors times the cosine of this angle. Let's look at some special cases. When two vectors are perpendicular to each other, the angle between them is 90 degrees. The cosine of 90 degrees is 0, so the dot product of perpendicular vectors is always 0. When vectors are parallel and in the same direction, the angle between them is 0 degrees. The cosine of 0 degrees is 1, so the dot product equals the product of their magnitudes. When vectors are parallel but in opposite directions, the angle between them is 180 degrees. The cosine of 180 degrees is -1, so the dot product is negative the product of their magnitudes. Now, let's see how to calculate the dot product using components. Assume we have vector A with components A_x, A_y, and A_z, and vector B with components B_x, B_y, and B_z. The dot product is simply the sum of the products of corresponding components. A_x times B_x, plus A_y times B_y, plus A_z times B_z. Let's verify this result using the angle formula. First, we find the magnitudes of vectors A and B. The magnitude of A is the square root of 3 squared plus 2 squared, which equals the square root of 13. The magnitude of B is the square root of 4 squared plus 1 squared, which equals the square root of 17. To find the angle between them, we use the dot product formula and solve for cosine theta. We get 14 equals square root of 13 times square root of 17 times cosine theta. Solving for cosine theta gives us approximately 0.92, which corresponds to an angle of about 23 degrees. Let's discuss some important properties of the dot product. First, the dot product is commutative, meaning a dot B equals B dot A. Second, it is distributive over addition, so a dot B plus C equals a dot B plus a dot C. Third, when multiplied by a scalar, the scalar can be moved outside. A dot K times B equals K times a dot B. One of the most important applications of the dot product is in physics to calculate work. Work is defined as the force applied to an object multiplied by the displacement in the direction of the force. Mathematically, work equals the dot product of the force vector and the displacement vector. Another important application is finding the angle between two vectors. By rearranging the dot product formula, we get cosine theta equals the dot product divided by the product of the magnitudes. This is particularly useful in 3D geometry, where visualizing angles might be difficult. Let me share some tricks and tips for working with dot products. First, when you need to find if two vectors are perpendicular, just check if their dot product equals 0. Second, to find the component of one vector in the direction of another, divide the dot product by the magnitude of the second vector. Finally, the dot product of a vector with itself gives the square of its magnitude, which can be a useful shortcut. Let's summarize what we've learned about the dot product. The dot product of two vectors is a scalar that equals the product of their magnitudes times the cosine of the angle between them. Alternatively, it can be calculated by multiplying corresponding components and adding the results. The dot product has important applications in physics and geometry, including calculating work and finding angles between vectors. Remember the key properties. It's commutative, distributive, and works well with scalar multiplication. Thank you for watching this video on the scalar dot product of vectors. Remember to practice with different examples to solidify your understanding. The dot product is a fundamental concept that you'll use frequently in your mathematics and physics studies. Good luck with your studies.